Give 5 more minutes. Okay, shall we start? Done. Okay, shall we start? Okay, let's start. I'll call out the names. You have to answer. Okay. First one, we have how many rows and groups are there in the periodic table? Okay, Ayush, can you tell? Please, everyone, give the answer in the chat. Be quick. Yeah, everyone. Yes, 7 periods. What about groups? Yes, correct. 7 rows and the horizontal rows being the 7 periods and our 18 groups, that being the vertical columns. Correct. Second one, we have been given 5 different elements. You have to tell the elements that are in the same group with reasons. Okay. And then the elements that are there in the same period as well. You have to tell, okay. Give the answers. The elements that are there in the same group will be having the same properties. And as you gradually move from left to right in a period, yes. Next one. Okay, Hishikesh, can you tell me the next one? The answer of the second question, A part. Yeah, the second A part we have in the same group we have beryllium, uh, F and K as well. Yeah. What about beryllium and fluorine? Are they in the same group? Nitesh, fluorine and potassium are not in the same group. They are in a different group. Potassium is an alkali metal, while your fluorine is a halogen, right? Yeah, beryllium and calcium are in the same group. Correct. Just do the third one. Same period, it can be beryllium and fluorine. You have two different elements with atomic number 17 and atomic number 20. So you have to tell the position. Please answer this one. Yeah, potassium and silicon they are in the same period, and as they have same valence electrons. Yeah, they have same number of valence electrons as well. Correct. Okay, third and fourth one, quickly give me the answers. After that, we will start the specimen paper. Can you get the charger? Charger. In the back side. Okay, I got disconnected. Let's do 8th question. Sodium hydrogen carbonate when added to acetic acid evolves a gas. Which of the following statements are true about the gases evolved? Okay. So do this one. I want the answers in the chat. First of all, tell me what will be the gas evolved. Arushi?
So,
Yeah.
can you repeat the question?
Yeah, this 8th one. Is the question not visible? This 8th one we are doing.
So now it's visible. Give me 2 minutes. I'm just reading the question.
Okay. Okay, Devanshi, it says first and fourth. So pungent odor with turning lime water milky, they do not match actually, right? If it turns lime water milky, it should be CO2. What's your gas, Devanshi? Can you please tell?
Sir, it is CO2. I don't know about its characteristics.
Okay, it is CO2. So yeah, it turns lime water milky. That's correct. Will it dissolve in a solution of sodium hydroxide?
I
If
think
it
the
is
answer is A.
okay, so your gas is CO2, right, Arushi? So yeah, if CO2, the characteristic is that it turns lime water milky and it extinguishes a burning splinter. That is, it is a non-supporter of combustion. Right, and the characteristic reaction that we are using is your bicarbonates or your hydrogen carbonates, you can say. They with acid gives you salt plus water plus CO2, right? So carbon dioxide gas, yeah, it will turn lime water milky and it will extinguish a burning splinter as well. Okay, to the next one. Aluminium is used for making cooking utensils. Which of the following properties are responsible? Correct, good thermal conductivity. Electrical conductivity we don't need actually. High melting point, no, it's ductility, but ductility will not support the cooking. You just need a good thermal conductivity, and that is provided by aluminium, right? So yeah, that's correct.
But sir, we have to choose any two from them, right?
Yeah, so okay, so that should be then first and fourth, then we can do, because electrical conductivity and ductility won't be helping, right? So if you want to like do cooking you will usually do at 100 150. So the melting point is above that. So yeah, if you want to have two of them, so good thermal conductivity and high melting point you can use. Okay, and even ductility, but ductility is the ability to form wires, right? It has no use in your cooking. Okay, If it was malleability, then also we cannot take. Malleability is about making sheets. There is nothing we can do in cooking or in making utensils, right? Let's select a different chemistry question. Okay, let's do this one. Read the following and answer any 4 questions. So thermite reaction, let's leave it. Okay, this is, I think this isn't in the course. Okay, let's do this one. Identify the acid and bases from which sodium chloride is obtained. Which type of salt is it? Why is it called, when it is called a rock salt, and how is rock salt formed? Yes, I will ask one of you to explain. Okay. Yes, acid is HCl. Correct. Can somebody speak out the answer? Zohaib, can you do it? Can you explain the entire thing? Yeah, acid is HCl. That is correct.
Yes, sir.
Okay.
So
Yeah,
the acid is HCl and the base is NaOH.
correct.
Yeah,
Yeah.
so when HCl will react with NaOH, it will give NaCl plus H2O.
Yeah.
Yes, sir. So 1 minute.
Yeah, you can just write
Yes,
it down.
it
Yeah.
is. Yes, sir. So it is called as rock salt because seawater has many dissolved salts in it.
Correct.
So sodium chloride, when it is separated from these salts, deposits of solid salts are found in many places in the world. So large
Correct.
crystals are often brown due to many impurities in it, and this is called as
Okay.
rock salt. So it is formed when beds of it is formed when the beds of rock salt had dried up by the bygone ages.
Yeah, but after the drawing process. Correct. Correct. Very good,
Yes.
Zohaib. Yeah. Okay, next one. Okay, this was completely correct. We have acid as your HCl, then your NaOH, which is a normal salt, and it is being called rock salt because seas, the deposits are there, the NaCl or even different salts are there that are there in the seas that keep from getting deposited on the salts. And that is why it is termed as rock salt, or the salt formed in those rocks. Basically, how it is formed, you just have to do the evaporating thing, or you can say the crystallization thing, where you dry out the water, and as a result you get the rock salt or our NaCl as the final product, right? So next one, for the preparation of cakes, baking powder is used. If at home your mother uses baking soda instead of baking powder, how will it affect the taste of the cake and why? First of all, everyone write down the formulas: baking powder and baking soda. Let me just check. Okay, Devanshi, can you answer it? The first part.
Yes, so
Yeah, say.
so can I read it first? For the preparation of cakes, baking powder is used if at home your mother. So sir, it will make the cake a little bitter because baking soda when heated gives Na2CO3, and that's a mild base which is bitter. So hence it will affect the taste of cake.
Yeah, so the taste will become bitter. That's correct. Okay. Baking soda plus tartaric acid gives you baking powder. Okay, that's correct. The second one, you can convert baking soda into baking powder, mixing it with tartaric acid. What makes the cake soft and spongy, Arushi?
So the white gas which is released makes the cake soft and spongy.
Which gas?
So carbon dioxide, CO2.
Okay, CO2 gas, which released or escapes out during the cooking, usually makes it spongy. Correct. Quickly do the next one. Okay, 34th A part. Everyone. Okay, everyone write down in your notebook. I can ask any of you, right? So, Adit, you have to answer the next one, 34th A part. Hello, Adit, are you there? Please give me the answer. How you can differentiate between metals and non-metals? 3 points you need to tell.
Sir, you called out my name.
No, Adit. You want to tell?
Okay. Yes, sir, I can tell.
Okay, tell me. Okay, tabular
Okay.
form
Yes.
and make the table.
So
Just a minute.
first,
Okay, we have metals.
yes.
We have non-metals.
First is
Yeah.
ductility.
Okay. Metals are ductile.
Metals are ductile.
Non-metals are.
Non-metals are not ductile.
Okay. Can you call them brittle?
So don't we need to say the
Metals are not.
chemical properties?
Yeah, you have to say the chemical. Yes, she's correct actually. These are physical ones. Okay. But the question was, can we call the non-metals brittle? Not really, right? Okay, first difference can be in terms of oxides. Oxides of metals are basic in nature, right? And where we can say that oxides of non-metals are acidic in nature, correct? This can be one of the chemical properties. So example, you can have calcium oxide, that is basic, carbon dioxide being acidic here, right? Like this you have to tell. Give me other properties quickly.
So can I say one?
Yeah, say.
So all metals react with diluted acid to form metal salt and hydrogen gas, whereas non-metals do not react with dilute acids.
Yeah, your metals react with acids to give you hydrogen gas. Here, they do not react with acids. What do we call metals that can react with both of them, like acids and bases?
So metallic oxides, right? They are amphoteric oxides.
Metallic oxides, not all of them are amphoteric, not really. You have,
No, sir, the metallic oxides will react with both acids and bases. They
yes,
are
yes,
amphoteric.
yeah, they are amphoteric oxides. Okay,
So
so
reactive metals can displace less reactive metals
but
from their
that,
compounds.
yeah, but that thing is there for non-metals as well. So that's really doesn't make a difference. Non-metals also do that. For example, if you have chlorine and you want to make it react with NaI, okay, that thing happens. Your NaCl is formed and iodine is formed. Okay,
Yes,
so
sir.
yes, so that is not really a difference. But yeah, you can write that. It won't be wrong completely. Any other one? Yeah, this way I was telling you. Meanwhile, you think about it. Amphoteric oxides, okay. There is a term called amphoteric metals as well. Okay, and these are the metals that can evolve hydrogen gas with both acids and bases. Okay, and we have amphoteric oxides that can react with both acids and bases. Okay, okay, chemical property, can you tell me one more?
So can we say that non-metals do not react with water, while metals, some metals react with water to produce metal oxide or hydroxide and hydrogen gas?
You can say it in this way that your metals can, some of the metals can evolve hydrogen gas actually, but non-metals do not do that. Yeah, that can be, but yeah, but yes, you can say that react with, but all of them will not do this, right? React with water to produce your hydroxide and hydrogen, right? And here you have do not react, but there are some metals that can actually react with. Okay, what else can you write other than the chemical ones? Physically you can write all of them, like ductility, malleability,
Luster.
sonority, luster. Okay, that's it. Rusting is not there in the course, I guess, right? Okay, this we have done all the chemistry questions. Okay, write the number of covalent bonds in the molecule of butane C4H10. C4H10. You know how to draw it? I don't think it's there in the syllabus. I mean, homologous and carbon is only there. I'm making it for you, okay? You just have to count the covalent bonds. Okay, so we're saying 13. That's correct. You just have to count the single bonds. You have 1, 2, 3, 4, 5, 6. Let me just show you the different color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay, so there are 13 covalent bonds in a molecule of butane. Okay, state one reason for placing magnesium and calcium in the same group of the periodic table.
So they have the same number of valence electrons.
Yes, they have the same number of valence electron. They have identical properties. One of the reasons you can write, yeah, with the same number of valence electron. How many valence electrons?
2.
Yeah, 2 valence electrons. Okay, 2 solutions X and Y are tested with universal indicator. Solution X turns orange, whereas solution Y turns red. Which of the following, which of the solutions is a stronger acid? Okay, so correct answer. Okay, who will tell? Hrishikesh, can you please tell the answer? Okay, so you explain.
Sir, because on the pH paper, the colors of stronger acids are red, whereas the colors of weaker acids are kind of orangish.
Yeah, you can just compare with that as well. This is one way to remember, and obviously you can actually remember the colors as well. But one way to remember is as you move toward the stronger acid side, your color keeps on getting reddish, right? Because our acids turns your litmus from blue to red. So ABR like that. You remember you're going towards the acid side, you keep becoming red, right? So Y should be your answer. Okay. Make a distinction between metals and non-metals with respect to nature of their oxide. This we have already done just now. Your metallic oxides are basic and your non-metallic oxides are acidic. Why so? Can anyone explain? Arushi? Why your metallic oxides are basic and non-metallic oxides are acidic in nature? Devanshi, can you please tell?
The non-metallic oxides are acidic because they react with bases to give salt and water, and metallic oxides are basic because they react with acids to give salt and water.
Okay, Arushi, enjoy the meal. So you have that is one way to explain. The better way is to show the reaction with water actually. Okay, so you have metallic oxides and you make it react with water, you get what? You get metallic hydroxides. and you have your non-metallic oxides. They react with water to give you what? Acids. Okay, so metallic hydroxides are what? They are bases, right? And here you have acids. One example, suppose you have Na2O, that is the oxide of a metal. In your water or in your aqueous solution, it will give you NaOH formation. That is a base. That is showing you the basic nature of your metallic oxide. Suppose you have CO2, that is a non-metallic oxide. You make it react with water, it will give you what? H2CO3. That is an acid. Name carbonic acid. Okay. Similarly, you have another one, SO3, sulfur trioxide. It reacts with water, gives you what? H2SO4. Again an acid. Okay. This is how you can just prove basically the metal oxides are basic in nature. Now, using this thing, can you please, again, anyone, if you please tell me how to prove that your ammonia is basic in nature? NH3. Look, your ammonia in NH3, make it react with water. It will form NH4OH. That is a base. Okay, so anything that is basic in nature, you dissolve it in a neutral solvent or a neutral substance, that is water, and it turns the neutral solvent or the neutral substance water into a basic solution, right? That shows the basic nature. This is a base. Okay, this is how you can just simply tell whether a substance is basic or acidic in nature. Okay, uh, let's do another one more before we end. Okay, write the molecular formula of the second and the third member of the homologous series whose first member is methane. Okay, correct. Adit, can you tell this one? Are you there? Rishikesh, Adit, you guys are not answering. Very bad. Okay, Devanshi, want to answer?
Sir, C2H6 and C3H8.
Correct. So what you have to do, you just have to keep adding CH2. So your methane
Yeah.
is CH4. So you add CH2, it will become C2H6. Then the next one will be C3H8. You can keep on continuing like this, C4H10. This is your C4H10, butane, fourth member of the alkane family. Okay. Okay, fine. Let's stop here. The rest we will do in the next one. Okay. Any doubts you guys have? You can ask right now. No doubts?
No, sir.
Okay, so ending this, okay?
Yes, sir,
Bye-bye.
no doubt.